AutoLine After Hours is brought to you by Bridgestone Tires, solutions for your journey.
Hey, Gary.
John, how are you?
Gary, I'm doing pretty good. I'm very excited about today's show, and I think our audience is going to be blown away by some of the things they learn.
I would agree with you. I want to start the show. I want to ask you a question though before we get into what's going on. Okay, so last week the car company Byton filed for bankruptcy. Okay, and I noticed that in 1940 on January 13th, Hupmobile ceased to exist. It had a 30-year run. And okay, so we're going to be talking a lot about technology. And so here's my question to you, because you know a lot about this, the industry at large. How many of the nascent car companies that exist do you think will last for 30 years like Hupmobile did?
Obviously, I believe Tesla is going to survive and thrive. I think in China, BYD, boy, they look to be the real deal. Lucid, I don't know. I mean, they need volume, and they're priced at the high end of the market where it's hard to get volume. Rivian, look, I still think Rivian's got a good shot at it, because they're on the commercial side and on the retail side. But the rest of them, I don't know. Boy, it's getting real tough out there. What do you think?
I think there are a lot of companies that have grand expectations and little possibility of achieving those expectations despite their best efforts. I think that we're going to see some shifts. I think that some companies are going to become more important and some companies become trivial, and it's going to be a real problem. And with all of the money that had been invested in this whole space, it's very unusual. But yeah, I just thought it's sort of interesting to think about companies that existed, early on in the industry when there were so many, and when Hupmobile got in, they were like, it became the 8th big car company. Okay, but that's a relative thing. In 1909, big car company, but I just want to get your thoughts on that, because I think it's relative to what we're talking about in the show.
It is. So we've got 4 winners of the GAMIC contest. GAMIC is Global Automotive and Mobility Innovation Challenge. For those of the viewers who are familiar with Shark Tank, the television show, this is kind of a Shark Tank, but for automotive innovation, with inventors and companies that are breaking into the auto industry. And GAMIC, the executives who founded it, are largely retired automotive executives, not fully retired, obviously, and they get entries literally from all over the world of companies that want to win this award. And then they evaluate it, and they've got experts in mechanical engineering and electronic engineering and you name it. And they pick the best of the best. And we've got the 4 winners on today's show. So let's bring them in. We've got Chance Claxton and Marcus Hayes from a company called Orbis. We've got Damien Despinoy from Volexion. We've got Yuanbo Guo from Vultara, and Michael Pickholz from MagWorks. And hello to everybody out there.
Hello, John.
Hello. Hey, John. Gary.
Hello, Gary.
So let's go through very quickly just to give an idea for the audience. Orbis has come up with this new design for brakes that is going to knock you out. Volexion is using graphene for the cathode on lithium-ion batteries. They've got a really good story to tell there. Vultara has got software as a system for cybersecurity in cars. And MagWorks has got a new design for lighting headlamps in cars that is unlike anything else that's out there. And if I got that all wrong, you guys correct me as we get to talking about it all. But Chance, Marcus, why don't we start out with you guys at Orbis Brakes? Tell the audience why I think you've got such a breakthrough on your hands there.
Mm-hmm.
Thank you, John. We're really happy to be here today, and we were honored to be one of the winners at GAMIC. just a plug to GAMIC, it's been a really interesting exposure for us, and we've received many introductions on behalf of that exposure, and just the inroads of reaching some of these people that are harder to reach has been really nice. But we are what we like to say the future of braking. We have a novel brake that runs 50% cooler and is 50% lighter than brakes on the road today. So it is addressing what are quickly coming to be a reality of braking regulations. In Europe, they have the Reg 7 coming out that particulate matter in brakes will be becoming much more stringent. India is following suit, as is California. So what we're doing is pretty exciting, not just for lightweighting and pollution, but also just saving costs on the manufacturing side with what we're doing in our brakes.
So Chance, when you're
tell
talking
us a
about
bit more about, sorry, go ahead, Gary.
No, I was going to say, when you're talking about the brake being lighter and cooler running, I mean, but are you doing this with exotic materials, or are you doing this with materials that people who make brakes are familiar with?
Good question. So to speak to what you were saying before, it's we are shifting what has been happening in the braking industry. So as I'm sure most of your audience is familiar with, carbon ceramic brakes and all of the benefits that carbon ceramic offers. Well, we are bringing with our ductile iron brakes to market similar benefits.
So low-cost gray iron is
Yeah.
doing what in the past it took carbon or carbon ceramic to do. So conventional mass
Marcus,
production
explain a
materials,
bit.
high volume.
Marcus, explain a little bit more about the design, because it's not like ductile iron is lighter than ceramic or anything like that. You've got sort of a ring, outer ring that is literally the rotor of the brake.
Exactly. Well, it's super interesting, John, that the mass, as you no doubt know, and we won't get too technical, but everything in the center of a conventional disc brake is really just excess weight, as we've discovered. The virtue of our technology in the big ring is effectively a pump. It pumps air. And as the inner diameter of the circle, which is in our case a big donut hole, as that donut hole gets larger, we pump as much as 3 times more air through the interior of the rotor. So we can have the same braking effectiveness as a conventional rotor, same mass production materials and processes, but half the weight, as Chance mentioned, half the temperature. So we're running typically 50% more coolly. And then finally, we can use a brake pad that's half the size for the same amount of braking energy. And that's where we reduce brake dust, which is, as Chance mentioned, a Euro 7 regulation, new regulations on toxicity of brake dust emissions. So we address these growing concerns around particulate emissions.
And you're also reducing unsprung mass, which is really going to help the ride and handling and steering of any vehicle that uses these.
Indeed. Well, so as we know, the weight of the wheel assembly dictates many things, safety, control, comfort, and the lighter the wheel is, as you know, then the improvement happens throughout the experience of the automobile or the truck. So it's an exciting technology, because normally, as you know, you have to spend more to get less in terms of weight. And this really is the reverse of that. We can have no increase in cost, but derive the benefits that would normally be limited to exotic materials.
I was just going to say, you were mentioning the particulate
you're also
issue. See, John and I are stepping on each other, so you guys were briefed earlier about this happening.
We're too excited to talk about it.
And we're doing it. So the question about the particulates. Okay, so you're using iron rather than the carbon ceramic material. So it seemed to me that the carbon ceramic material would have less possibility of there being things flaking off. And I got to imagine that when you're applying pressure to a cast iron rotor or disc, whatever we want to call it, that there would be, a greater likelihood of that. Is that an issue, and how do you address it?
Well, it's totally an issue. And so the goal is to have a low-cost solution for this extraordinary problem. And the interesting thing about the way the brake cools is UK Birmingham, for example, was the first institution that sort of made this discovery about the problem of brake particulate, particularly in London, no pun intended. In any case, brake temperatures, according to now multiple studies, were shown to be responsible for a 10,000-fold increase in brake dust as brakes get hot. So the first thing you have to do, carbon, ceramic, and whatever the material is, iron, it has to be cooler. And so having a rotor now that runs at half the temperature of conventional is the threshold that, and the crucial threshold is approximately 180 degrees centigrade, but we stay below that crucial threshold so that we never see that kind of toxicity or that plume that occurs. And then our because the leverage and the diameter of the ring are bigger, we get to use a pad that's half the size for the same force. So between the pad size, the better cooling, the improvement in the diameter of the circle, we get these virtues with mass production cost.
I would imagine that the racing community would be all over this, because better braking, more air going through it for better cooling, and of course, lighter weight.
Well, there's certainly an application in motorsports. It's one that we are looking at with strategic partners who have more expertise than us in that field. So the technology is one where we can hand it to various experts. Our focus is mass production, trucking in particular, and electric cars. It's unfortunate that it's turning out that the EV, because of its typical weight being 25% more than an internal combustion engine, there is this assumption that regen does all the braking. Well, according to the European Union studies, they've called out EVs particularly for this problem of excessive dust. And so in all the braking world, testing, whatever the processes are, there is a requirement that the brakes be tested independently of the electric motor. And so there are, unfortunately, a lot of high-profile documented failure of conventional brakes in high-performance electric cars. So the EV industry needs us as bad as anybody.
Good stuff. Well, we'll come back to that, but let's move on to Volexion. Damien, tell us about this graphene and what you're doing with cathodes.
Yeah, happy to. So first of all, the technology that we are commercializing at Volexion is a advanced materials technology coming out of a collaboration between Northwestern University in Chicago and Argonne National Laboratory in Chicago. So two world-class centers when it comes to material science and batteries. And I'm personally passionate about the energy transition. I think the automotive industry has a huge role to play, and there's been a realization over the past few years that the Detroit community definitely needed to be leading the charge. So that's how I got connected with GAMIC. And what makes Volexion different in this space is electric vehicles are still relatively expensive. We absolutely need to improve the performance, improve the safety, and reduce the cost of lithium-ion batteries. So there needs to be innovation all over the components of lithium-ion batteries. And if you look over the past 10 years, there's been a ton of innovation. So there's three major components in the lithium-ion battery. There's the anode, which is the minus side, the electrolyte, which is the liquid, and the cathode, which is the plus side. And 95% of the innovation over the past 10 years has been focusing on the anode and the electrolyte, whereas the cathode is the limiting factor when it comes to packing more energy in your battery. And it's about 40 to 50% of the cost of a lithium-ion battery. So it's definitely been a component that's been underserved by innovation, because it's very hard to innovate in this space. These are very advanced materials that have been fine-tuned over the years. So getting to the next next step change in performance is not easy to achieve. So that's why we need world class scientists to achieve that. So our technology essentially consists in encapsulating and putting lithium-ion cathode materials directly in a cage of graphene. So you can see in the schematic on the top left that we essentially apply a continuous, very thin nanoscale layer of carbon, structured carbon at the surface of the cathode materials. And the trick is to make sure that the atoms of lithium that needs to travel in the battery, otherwise you would choke your battery. So they have to go through this coating, and we have proprietary technology to enable that. But we also want to create this separation barrier between the material and the outside environment so that only the lithium can be exchanged and the metals stay with the cathode materials and the solvent stays with the electrolyte. So this way there's less degradation, there's more power, there's the ability to operate at higher voltage, which allows you to pack up to 15 to 30% more energy in your battery, which reduces cost. And at the same time, graphene happens to be one of the most conductive material that's been discovered out there. It's more conductive than significantly more conductive than copper. It's 200 times stronger than steel, so it's the right tool for the job.
So basically, explain this to us. So basically, it's like an M&M is candy surrounding chocolate. Okay, so you've got a graphene material surrounding what, and how do things move through it in a way that's acceptable?
Mm-hmm. So yeah, that's definitely that's a coating technology. So it's a surface treatment, and it's what we impact is the last nanometers of the cathode material. So a cathode material is essentially it's a particle of metal oxides. So nickel, manganese, cobalt, aluminum, these type of metals that are well arranged during the synthesis process. And during the lifetime of the battery, they get exposed to very high voltage, very high corrosive environments, which are brought by the electrolyte. So you do need that surface treatment that essentially protects them and isolates them, stops the spread of the initial defect that then is going to kill your battery, actually. So there's coatings in the industry, but none of them is done with graphene because graphene is a tough material to be able to handle, and it happens to be a superior tool for the job compared to what's out there, thanks to the conductivity and the mechanical strength of the graphene, essentially. So what we're trying to do is making sure that the coating lets the lithium needs to move between the plus and minuses of the battery. It needs to go in the material, outside of the material, in the electrolyte, across the battery, in the negative pole. So they need to be able to move freely. And so what we do to enable that is we introduce the right amount of atomic level defect in our coating so that the lithium can move through. But if we introduce too much of these defects, then the metals can actually dissolve and move and get to places where we don't want them to be. So it's really engineering the quantity of impurities and defects in our coating that allows us to make it transparent to lithium, but also completely like an insurmountable barrier to everything else. Did that answer your question?
Yes. So let me follow up on this. So if someone is making batteries right now,
yeah,
could they take your process and add it to their process and get better batteries as a result, or does this have to be designed from the get-go?
No, so it's a platform technology. It's applicable across. So battery chemistries are very complicated, and our technology is pretty versatile, and it can be applied across a broad variety of chemistries. So we're currently focused on what is called, nickel-rich NMCs, which happen to be the immediate next generation of battery cathode material, and they have a lot of problems in terms of stability and cracking and degradation. So yeah, we are collaborating with a cathode material manufacturer, battery manufacturer, and OEMs, including in the Detroit area, to work with them on their application of choice. So they have preferred materials that they either synthesize themselves or get from a supplier. They've already established like a prototype and a preliminary design of a battery, and they're always looking for extending the life of the battery by as much as they can. So in our case, it's typically 2 to 3x that we observe. So we collaborate with them and we take the material, we apply our technology, which is pretty easy to transfer from material to material, and then we collaborate with them on qualifying and designing the battery in a way that takes the full advantage of our graphene coating, essentially.
Thank you.
But one point that's
Damien,
worth mentioning. It's that our technology, we apply it at the powder level. So we take a material made by a chemical manufacturer, think BASF, think Umicore, think Nano One, and what comes out of our process is a powder that's exactly of the same form factor as what came in, which means it can be directly utilized by the battery manufacturers, which are the Panasonic, LG, and LG and Samsung of the world, directly in their existing line with minor changes to manufacturing equipment. That's also a big plus of why our innovation is generating good interest in the industry.
Damien, I would imagine if this is making batteries last longer, probably more efficient. From a total cost standpoint, what does that do to the battery system?
Yeah, so that's also part of our innovation. You're right. Graphene is a wonderful material, as I was mentioning. It's several hundred times stronger than steel, much more conductive than copper or anything out there, both thermally and electrically. Graphene is only 20 years old, and there's been so far challenges to scale it up and to industrialize it. And that's where one of our breakthrough comes in as well. Is we have a secret sauce to improve the productivity of the graphene synthesis by a factor 100 compared to a comparable process. And then we also have a relatively low-cost process to apply the graphene coating. Essentially, we use glorified food and beverage equipment to apply the coating to cathode materials, and we have line of sight to deliver the coating by adding less than 1% to the cost of a lithium-ion battery, while enabling up to 30% cost savings thanks to energy density improvements compared to today. So the net equation is definitely in our favor. Yeah.
So you mentioned metals like nickel, cobalt, and aluminum. One of the growing types of batteries is LFP, which uses iron. Is there applicability there?
There is applicability there. We haven't been focused on LFP as much as on the other ones, because right now the Western battery industry is more focused on NMC. LFP is extremely big in China, and there is definitely a trend to grow LFP in the West as well. With that being said, it's one of these questions, which chemistry is going to win in the EV industry? It's one of these questions. We're going to ask the same question in 20 years, and it's still not going to be clear. I remember when I started in the lithium-ion battery industry, it was about 10 years ago. We were wondering, are we going to have batteries that are, cylindrical, that are pouch cells, or that are prismatic? It's still the same question going on today. So I'm pretty sure from a chemistry standpoint, we're going to have the same debate in 10 years. So there's a couple of things with why our technology would work on LFP. Let's make it clear. LFP has huge problems of electrical conductivity. Cold temperature performance is not what it is not where it should be. It's moisture sensitive, and our coating would help with that. With that being said, LFP is extremely cheap, and so it's very hard to introduce a new technology, even though our cost projections are relatively low. The first use case is going to be comparatively more expensive, so it's hard to take the cheapest material out there to make it your first use case, essentially. So we are more focusing on the high performance, high-end side of the market for our first application, but then we can deploy it to other chemistries down the line. There's also something worth considering when it comes to LFP, is that So yeah, that's why I was saying it's one of these debates that will not have an answer in the industry. It's when you take into account the recycling cost, you actually have to pay for a recycling fee for LFP, and the value of the metals that remain in what comes out of your recycling process is zero. Whereas for NMCs, which have nickel and cobalt, they have market value in the market. So when you take the total life cycle cost of the battery, including the recycling and the residual value of the metals that you get out of the recycling, the equation is a little less in favor of LFP as it is if you look at a first cost perspective, for example.
Hey, look, before we get into Vultara and MagWorks, this is probably a good time to take a commercial break halfway through. So let's give a shout out to our good friends at Bridgestone.
How do Bridgestone tires stop shorter on wet roads? It's their HydroTrack technology. But you don't have to know how the science works, just where the brake is. What really matters is their Bridgestone.
And we're back talking with the four finalists, the winners from the GAMIC Innovation Challenge. And Yuanbo, let's talk about Voltara. And I'm intrigued. Your SaaS, right? Software as a system, is that right? Or service? And you're all into cybersecurity. You take it from there.
Yep, you're right. SaaS stands for software as a service. So what do we do? First, before I explain what we do, I want to clarify a popular misconception. When people hear about cybersecurity, their first, the initial impression is always trying to guess, is this a new type of firewall or new type of encryption which going to stop the hackers, right? So those kind of product, as a security professional, we call it technical control, which is some mechanism will directly prevent attackers from hacking into some kind of system. But that's not what we do. What we do is automate cybersecurity engineering processes. So we have a suite of SaaS software product that helps automotive cybersecurity engineers to automate different sections different phases in this entire cybersecurity engineering development and production journey that traditionally are done in hundreds, if not thousands, of Excel spreadsheets. We help automate that into using different kind of web-based software application. For example, our flagship product, which is Tara Automation, part of our name. Tara in automotive security world stands for threat analysis and risk assessment. It is a particular type of work product required by the ISO SAE 21434 standard, which is like the Bible in the automotive cybersecurity world. We replaced the traditional Excel spreadsheet experience into a circuit simulation type of experience. Any electronics engineer or embedded system engineer can just drag and drop components and put them into a circuit kind of system diagram and then click run, and then the tool will generate the reports that ISO standards ask for. Right, it's all automatic. So that's what we do: help automate the security engineering process.
Okay, so let me ask you a question to sort of maybe get into this a little bit more. So on your website, there's a quote that I'll read to you and then explain what these bits are, okay? Mm-hmm. So it says, in a cyber physical system, cybersecurity is no longer a software engineering task. It requires systems engineering. The right hardware needs to be matched with the right software via the right interface. So I'm wondering, what is a cyber physical system? What do you mean by cybersecurity is not a software engineering task? What is systems engineering? And what is the hardware that's involved in all of this?
Right. Yeah, good question. So that's actually one of our biggest differentiator from the thousands of cybersecurity startups out there. Most of cybersecurity, as you know, cybersecurity came from the internet software industry, right? So most of the software product out there, they actually help. If you make a website, you make a web application, you probably need some kind of software to help you protect your website. That means you're developing only a pure software product. But automotive is an entirely different animal, right? So as you know, traditionally, automotive has nothing to do with software. It's pure mechanical beast, and it now has a lot of code adding into it. Now it's really complicated. This so-called cyber physical system means that it's a hardware. You can touch it, right? At the same time, it has a cyber element into it, meaning it has some sort of networking uh, elements. It can be for the automotive. It can be the in-vehicle network, meaning that all the different electronics, they are actually talking to each other through electronics ways rather than mechanical ways. At the same time, I would say pretty much all the cars you can buy right now are connected somehow using for some kind of services. So there are cyber elements inside a mechanical or physical system. That's what a cyber physical system means. And system engineering is a for especially for automotive engineers. System engineering actually most of the work. I used to be a system engineer before I became a cybersecurity engineer. Uh, Primary work is dealing with how do you coordinate the work between the software engineers and the hardware engineers, right? The hardware engineers, they are designing the print circuit board. They are picking the different chips to put on the right place and then draw the wires, right? So make sure these chips are talking to each other. And then the software guys will write embedded code, which will be put into these chips. So as you know, that these two these two departments, they have to work perfectly, right? The chips has to function exactly as the software guys ask it to function, and then hardware design has to allow all the required functionalities by the software guys. So that's what system engineer come to play. They follow a structured process. For example, you have to have different kind of requirements, functional requirements, technical requirements, right? And then you decompose requirements into software guys. These are for you. These are for the hardware guys. They both have to do their own job. And then you came back and say, I will verify, have you really followed my requirement correctly? And I even do validation after the verification. So there's an entire system engineering process involved, especially for automotive. If you go ask the internet, software guys, IT guys, they usually, even though they know the word system engineering, is very different from what we automotive guys know as system engineering. That's why the traditional cybersecurity tools, if you directly try to borrow it from the internet world and try to just plug in, force it into the automotive cybersecurity engineering world, it doesn't work. Right? That's what we do. Our tool is specifically built for the system engineering in automotive industry, help them to work with the software engineer and hardware engineers work together more efficiently. Hope that answers the question.
Yeah.
Yeah. So Yuanbo, the bad guys, the black hats, are always coming up with new ways of attacking systems. It sounds like your way of doing things would allow automakers, suppliers, whomever, to respond more quickly to any kind of new attack that they've discovered.
Right. Yeah, that's a great point. So that's actually the main difference between, even though I say cybersecurity engineering is a new engineering discipline, you can see you can tell that it's in parallel to the software engineering, hardware engineering, safety engineering. Now you have this new leg called cybersecurity engineering. But cybersecurity engineering is unique in a way that this engineering team, their work does not stop at the point of the launch of the vehicle, right? Because as you say, the new attacks come us all the time, and computers getting faster, people getting smarter, new tools are coming out. I mean, how once you have a big lineup of products, when I say product, it can be a full vehicle, or it could be a one small like electronic module inside a car, right? So when you have a full suite of product portfolio, what kind of process or tools you have in place to monitor whether one of your thousand products has a new vulnerability being disclosed by, say, academic or in the dark web, right? Once someone found that, trying to sell it for malicious use case or financial gain, how are you able to first find that, and secondly respond fast enough to deal with that? So all these require a different sets of process and tools so that you can keep monitoring these information from different sources. So you know, hopefully, that as soon as the bad guys knows, you know at the same time. So before they could really launch the attack, you could deploy a new software updates or hopefully it's not recall to mitigate this kind of new vulnerability. So when it happens, either stop it at the root, or when it happens, it doesn't work that bad.
So to go back to the internet and to the home user analogy thing to help me understand this. So, okay, people can buy internet protection software, right? And they can download it on their machine and it'll protect them. And then if there's a new update that comes, and so that's coming from a third party. Now, there are products like that for automotive, that there are companies that will sell the car companies suites of software that'll allow them to protect their car from being hacked from various ways. So is your product for the writer of the software, the third party, or is it for the automaker's staff that is doing the cybersecurity work?
So I would say for both. Actually, not only both, but also like tier 1, tier 2s who are supplying components to the automakers. The main use case of our product is to meet the new ISO SAE 21434 standard and also United Nations regulations. These two, the standard and the regulation, they require a really lengthy process, which require a lot of work products. That those requirements are for all the suppliers, automakers, and the post-market third-party product providers. As long as you need to meet those requirements, you have an option: either use Excel spreadsheets or use our tool. So, so that's the use case. But I have one comment is on for these third-party software, third-party cybersecurity add-ons, right? I personally feel, just as a consumer, I just got a new car a month ago. So actually, I was offered a cybersecurity package as an option at a dealership, and it really put me into a difficult place. I'm in this space. I should support my colleagues in this area and pay extra, but I also know this for a typical auto car buyer, it is not a normal thing to pay extra for security, because I think as a normal car buyer, you assume that when you buy a car, safety and security should be something took for granted, right? Why if you're trying to sell something security, that give me a sense of, make me think, oh, if I don't pay you extra, is it gonna be not secure, or is it gonna be not safe when I drive it, right? So that really I think this kind of new product line is putting some of the car buyers like me put on this borderline, just overthink what the situation is. So one of the benefit our tool is providing is that we are trying to help the automakers and the suppliers when they design a car. They should be, if they are designed correctly, they're designed well and maintained well, and the automakers and suppliers, they are monitoring the vulnerabilities and doing incident response fast enough. You do all these practice correctly, the car should be designed secure and safe inherently without additional adds-on, right? So that's why at the beginning I said, for cybersecurity professionals, we have this group of technology, we call it controls, meaning they are something you have to deploy to the car. On the other side are the processes, meaning that you follow these processes to develop these these features. So the process is really, if you get these things right, you should know what kind of control you should put in at the first place. And these are the minimum things to make your car safe and secure. And then if things happen and you react fast enough, things will be all right. So just something came out to mind when you mentioned this third-party security suite of product. Yeah.
Okay, everybody wants to know. Everybody on this that's listening, everybody wants to know, did you buy the security package?
No. Because my impression is if I buy this $50,000 car, it should be safe and secure, right? That's my thought, without paying extra.
Right. That's like charging extra for door locks.
Right. So yeah, so there are so many things you can do software as a service to get additional subscription type of revenue. But my personal thought is like safety and security should not be monetized like that. But I do understand the difficulty of the automakers being responsible to put so much investment into security, which is something it's really difficult to say, difficult to sell for more money for a car, say, hey, my car is more secure than theirs. So they make this as an option, but that's just a dilemma. Still yet to be find out what's the best way in this industry to pan out.
Well, good. Let's move on to MagWorks, because I'm dying to get to this. Headlamps have become so important, that even the IIHS will not give you a top safety pick plus unless you've got really good lamps. So Michael Pickholz, tell us what you've done, the new kind of headlamp that you've come up with.
Well, once again, a pleasure to be part of this forum, as well as the honor of winning GAMIC. So a little bit of background. I'm been in automotive lighting for over 30 years, part of the traditional automotive tier 1 community, working on lighting as a whole. And the focus has been precisely, yes, when IIHS first came out with the top safety pick plus, got my attention. That was in 2016, just to give everybody a perspective, when the first requirement, when it began to push automakers to incorporate good lights, proper illuminating headlights as opposed to just lights that met the federal requirements. And the industry was like aghast. I said, why how they could do that to us? But it's a very good thing from my perspective. And because the focus has been, okay, if you buy a top of the line vehicle, maybe like Yuanbo did, and they'll throw in a set of good lights, right, for the package. But what about everybody else? So the point has been, how can you develop lighting that is cost effective? Picking up, for instance, the message that our colleagues here at Orbis propose. So low cost, lightweight, high energy efficient, but at the same time highly effective. And this also applies to the growing mobility industry, which is what our focus for MagWorks is, where because today there are very few independent lighting suppliers. By lighting, I mean headlights, which have similar, say, capabilities to the large tier 1s that supply the major OEMs, automakers in the world. It's a very interesting side-by topic, but what we've done is looked at new ways of extracting higher efficiency, higher performance from headlamps and delivering that with lighter weight. And so our core technologies employ on the weight side the use of magnesium, which is a interesting metal in that it can be injection molded. As a matter of fact, most laptop computers are made that way. Most people think they're plastic, but they're not. Most of them are not. Injection molded magnesium that allows to reduce the weight over a comparable aluminum part by 50%, for instance. And more recently, we introduced technology in the optical side, which is to employ a material referred to as optical silicon, which is basically very much the clearer version of what's on everybody's kitchens, right? In the way of utensils. So a material that is rubber, but crystal clear, just like plastics or glass. One-to-one alternative, if you will. But it has very unique properties. One of them being a very high temperature resistance, which is why it finds its way into kitchens. Much, much higher. I mean, significantly higher in plastics. And with that, we are able to extract a lot more light in conjunction with state-of-the-art optical systems that we can employ. So as illustrating here is let's say our best competitor's headlight in a city environment, and alternating that to our lamp in the same context, MagWorks low beam. You can see the much greater degree of illumination that we provide, while still being, of course, perfectly street legal, A, and B, meeting AAH criteria, which is critical. And this illustration right here shows a typical current low beam headlight, and then that is what we provide: much greater level of illumination, field of illumination. We're focused not so much in trying to provide greater distance as to provide greater width, so that people have the ability to see pedestrians in front, but also to the side, obstacles and the like, and avoid accidents. So this, for instance, is an image. This is virtual reality, by the way. These are not renderings. This is actually software that the automotive industry employs, top-end software, which is photorealistic. So what you see is represents what will happen in the real world. So here's a high beam, from a competitor, and switching to ours, so you can see far greater degree of illumination. And if you look to the far right, you will see a pedestrian walking by, which otherwise is clearly not visible. So we're quite proud to be able to introduce lighting that is, again, low cost, lightweight, highly efficient, both in terms of energy and illumination. So that's who we are in a nutshell.
So Michael, is what you're basically doing is taking, say, an existing LED type lamp, but repackaging it in such a way that using the magnesium to get it lighter and using the optical silicon to get that broader beam and the brighter beam?
To a great extent, quite right, Gary. For instance, a problem you have in LED is that they run the headlamp LEDs. They're very powerful, getting even more so every day, but they also deliver a lot of heat, which has to be cooled. So that's where the magnesium comes in, to be able to extract that heat, and it's a cooling system as well as a housing. So you get at least a two for the price of one, if you will, in that respect. So if you use plastics for the housing, you have to add what are referred to as heat sinks, which is typical in electronics, right? Everybody has a laptop, knows a little fan inside there blowing hot air. Same thing with a LED lamp. Either you have a fan or you have to have some other kind of way to extract the heat. On the side of the problem with the LEDs is because they aren't so hot, they run far hotter than the plastics that we normally have can tolerate. For instance, so of course, polycarbonate, as you and I have in our glasses, and which is the most common material, can only go up to 120 degrees, and LEDs go up to 135. So immediately you have a problem. You have a problem that if you are too close, they're going to start deteriorating, melting, yellowing, bad things. So you can't have that. So you have to keep a significant distance or ways to keep that from happening. Silicon, on the other hand, is good for 200 degrees. So you can literally touch the LED and you don't care. So that's one step there. The next one is the use of a type of optics which are becoming increasingly common, called total internal reflection, which is a little too hard to hand wave, but it means they have no reflectors. They're basically lenses that themselves capture the output of the LEDs and directed in a pattern that you intend to have, whether it be a high beam, low beam, fog light, or anything else. The issue with that type of technology is that there's no software written that you can buy off the shelf and therefore apply it directly. So it makes it the domain of the exclusive domain of highly trained optical engineers that know how to do it. So you have to know optics, you have to know automotive regulations, etc., and have a degree of expertise. So which means being around for a while. And that is what enables us to create systems which are far more effective. Now we're not trying to go after the automotive. We're mainly going after the mobility, but we're open, obviously, business to business, right? So, and there are many
So,
other.
Michael,
Go ahead, please.
you also came up with a headlight design for Aptera, right?
Correct. That's an upcoming project for us. The Vultara is a very interesting vehicle. It's extremely efficient, so it fits with our ethos as well. Theirs. We developed, and the Vultara has an interesting problem, that being a three-wheeler in the United States is classified as a motorcycle, and therefore the headlights have to be in the center of the vehicle by U.S. regulations. You can't go around that. NHTSA will make sure you don't. Therefore, we had to achieve, as a minimum, double the illumination capability from a single lamp than it's the most cars do with two. And that is one of our claim to fame, if you will, our achievement, that we can do so not only in terms of performance, but do so in lightweight, cost-effective, compact package. So, yeah, thanks for mentioning that, John.
So I have a question for everyone that I'd like to get everybody else to chime in on this. And it occurred to me that in all cases, each of you in your own way are facing entrenched competitors that have been doing something for a long time in a certain way that is accepted by the industry. So, how is it that you came up with the ideas of, doing your, the new braking systems, or the conformal coating, or the replacing spreadsheets, or coming up with new lamps? I mean, what was behind it, and how do you feel about, getting into the industry? Do you think it's a real solid possibility?
I'll jump
Chance, why
in.
don't you start?
Okay, thank you. In our case, our technology and the brake was born out of our sister company, which is called Orbis Wheels. You can sort of see behind us on this McLaren chassis, we have, it's an in-wheel electric motor, powertrain, drivetrain, and we needed to be able to fit all of that equipment within the wheel. So it was just it was born out of that. So we created the rotor, as you can see there, and all of the other technologies go within it, but it can live on its own too. So we realized that this had properties and opportunities onto its own. And whereas we are not in production yet, we are in talks with a few strategics, and just where we are within the, with ESG and with everything that's taking place, these sustainable solutions are going to have to take hold.
From our standpoint, as I said,
Damien,
our
how
focus
did
is
you...
Go ahead, John. I'm sorry. I was going to say, from our standpoint,
No, pick it up, Michael.
Yeah, our focus has been the rapid growth of mobility at all levels, not just automotive, but whether it be e-scooters, e-bikes, ATVs, UTVs, and there's massive transition, as everybody is likely aware, from internal combustion to electric. So the lighting industry is limited in the number of suppliers. Of course, if you are, again, a major automotive manufacturer, you have your established suppliers, and that's pretty much status quo, normal. But all these new manufacturers, there's really not an established small lighting supplier base, and there are many factors for that. Actually, interestingly enough, there are fewer suppliers today than there were about 6 years ago. And that's an entirely different topic of discussion, right, John? But it's a very interesting environment out there. And of course, all the things that we bring to that may not seem obvious with silicon is that being as a rubber is a very dent resistance. I mean, you can actually hit it with a hammer and it won't break. Therefore, one of the features we propose, for instance, for whether it be a city car, which is highly prone to be hit with whether it be a shopping cart, bicycles, et cetera, right? Running into things and people running into you. I'm referring to light damage, not heavy damage, but which is enough to damage the lights and break them and make the vehicle unappealing or generate cost. With our silicon, we are able to take a much higher degree of impact without breaking, damaging the lamps. So we feel that we're adding another layer of value to the product, right? Just like Yuanbo was indicating, there are ancillary benefits to the technology that are not at first obvious, but it's something that you cannot do with plastics. So.
And Damien.
I'll take it next. So I think the question was, how did I come up with the innovation? The answer is I did not. The answer is the research dates back over 10 years, and that's a collaboration between very advanced material scientists from Northwestern University and experts in cathode material from Argonne National Lab. And so this type of innovation in advanced materials is typically funded by federal institutions like the National Science Foundation and the Department of Energy. And in that case, the program that the tech that we are commercializing comes out of was focused on preventing the dissolution of a specific metal called manganese in lithium-ion cathodes, essentially. I think that started probably 8 to 10 years ago. So these innovations do take insane amount of times to come to market. So the role I have to play with that is at the time Professor Hersam, who is the inventor of the graphene technology, and a postdoc student of his who was our first director of research. They had taken the technology up to a certain point, established proof of concept, and they needed someone with expertise in manufacturing and management. And so that's about the time we met. And I was like, yeah, I can probably help accelerate that technology to market. And that's when I jumped on board. But yeah, when it comes to in the field of material science, these programs and these innovations tend to take a long time to develop. So you need to recognize the inflection points and bring in the right team as these inflection points happen, essentially.
Yeah. So for me, I think maybe maybe one thing different for us is that we do not have a incumbent, right? We did not back then, and even not today. There are a couple of startups trying to use different ways to solve the problem. For my own experience, is that I started this doing Tara back in 2016. I remember at that point I was working for one of the major automotive tier 1 suppliers. We reached out to external like cybersecurity contractors, and then we got a quote for doing 1 Tara. It cost more than $100,000, and the bill quickly adds up. I realized that it is impossible, because for every project you have to do multiple rounds of this kind of analysis, security analysis, and once you have multiple products, the price is unaffordable. So we had to design our in-house tools, and the first tool obviously was a Excel, because it's just almighty, right?
So you're competing with Microsoft.
right, yeah, and it's free, and so I guess all of other automotive companies, they came up with Excel following the same reason. They tried to go outside, it's too expensive. They tried to start inside, and Excel was just ready available. Just start putting things up, and but I don't think anybody enjoyed Excel, right? That's why I say there's no incumbent for our solution, even though everybody's using it, but everybody has different ways to hate it. And for my own experience, that is because I came from electrical engineering background. So if you think about the security analysis process, the first step is to draw a different kind of architecture on a whiteboard. And then you have a group of people just brainstorming where could an attacker comes in looking at this architecture, right? That's the starting point of security analysis. When I look at it with my electrical engineering eyes, I was thinking this just looked like a electrical architecture, right? And then for me, how to analyze electrical architecture is that you set, here's a resistor, here's a resistance, here's the voltage, and then you click run, you see the electrical currents, the diagrams, right? So that's just my thought coming from my background. So that's how I did it. I was like, this, if you have the, instead of drawing it on a whiteboard, why don't you draw it on the computer and then click run, and then you automatically give you the results. So that's how I came about it. That idea came out.
Well, real good. Look, we're at the top of the hour here. I want to thank all four of you, all five of you, I should say, for different inventions or innovations here for coming on the show. I hope the auto industry beats a path to your door, because I think what you've all come up with is really impressive and would absolutely make vehicles and our lives with them a whole lot better.
Thank you very much.
So with that, I think we'll wrap up today's show, and want to thank everybody who's been tuning in.
Thanks again.
Thank you, John. Thank you, Gary. Thank you all. Pleasure.
Yeah, thank you all.
Thank you.
Nice to be with you all.
AutoLine After Hours is brought to you by Bridgestone Tires, solutions for your journey.
If you like this program and would like to learn more about the automotive industry, check out our website at autoline.tv or look for us on YouTube on the AutoLine channel.